Okay, let's continue watching the remaining part of this on-site interview video.
Angle, left bound, second, it's angle, this one, and our next point and angle in point and angle between right bound, right bound plus 1, because we in this loop we want to check if we want to go broader or not, but it can be by mode of point and angle size, because point and angle size.
You can define size.
Actually we need to. We can simplify it, but later.
Yeah, okay, fine.
So, if this angle less than or equal than our field of view, so in this case we need to just to make a right bound be equal to right b plus 1 by model of this, let it be like constant or just constant, like n or a number of elements for simplify, right? Left, right side, like k number of elements, or right?
Yeah.
Like number of elements, like because num elements, or some kind of this, because it's shorter.
Okay. Yeah, fine.
So
yeah.
I just defined constant. So, all right, we just go there, and what we need to update current answer. So current result will be plus equal. We add the number of point in previous, or we can add the string here. Actually, all right. Let's current result plus or equal number of point and angle. We just plus 1, because I thought it's map, it's not count. Just plus
Yes.
current result.
Yes.
Sorry. And so right bound, right bound equal right bound plus 1 modular number of elements. It's
Yes. Some size.
angle size.
Yeah.
So after that we need to update our result, best result, like using just compare if current result.
Could you write over there?
Sure.
Yeah.
Just I write this is update.
Yeah.
Update.
So as you increase the current result, and then
Sure.
you're gonna go one more step toward the right, and then if the number of points from left bound and right bound is larger than the current best one, you're gonna update. Yeah.
So it will be pretty easy, I guess. If, for example, current result greater than, we can actually make a best result equal to -1, or for example 0 is also good. So if current result will be greater than best result, and in this case we need to update best result. So best result equal current result, and best result angle equal to to angle between.
Yes, output of that function.
Yeah, we can just write it here like double current angle, current field of view, field of view equal to this.
Yes, yes, yes.
in this loop, but it's maybe a good bad style. So, but we need we not have enough.
And this,
so
yeah.
Current current field of view. So
wait, field of view or angle?
Oh, I mean current. Like let it be angle.
Yes, yes.
Because it's
Yes, yes.
Angle.
Yes.
So we updated it, and we not need to forget about remove from current result number of left bound. When left bound goes, we need to from minus current result, because left bound also goes, right? So, and moreover, we need to write a current result equal to 1, because at first moment my left and my right bounds looks at this point.
Yeah.
So I thought, for example, in terms when we have an angle and the number of elements, I don't know why, but we all, and but we have only point only, and so
Yes.
only one, so we not need to care.
Yeah,
It's
because
gonna
you
be one.
already check the number of input points. There will be at least 1 point in the input vector.
Yeah.
So you can select one.
I tried to add here, for example, I have a couple of minor concerns.
Okay.
For example, if a user put a field of view greater than 2 pi or equal to than 2 pi,
Okay.
in in this case this will be infinite loop, so we need to check then input is check
Yes.
check the input less than less than 2 pi.
Yes.
2 pi, and also it's not greater, it's greater or equal, because if field of view only equal to 0, then we can see mathematically 1 point if field of view equal to 0, I guess. But it will work anyway.
Well,
but,
in this case, it's mathematical. Then it becomes a mathematics problem, and then I would say that field of view becomes a small number, greater than 0.
Ah, all right.
Yeah.
If field of view will be like 2 pi.
Yes, yes.
And in exclusive
Right.
bounds. So
yeah, exclusive bound.
It will be perfect.
Yeah.
So also one concern that when we try to write some kind of this one, we need to write some epsilon.
Yes.
Because it's pretty easy to explain, because we never compare a double like A equal B. No, we just minus and check model
I see.
abs of this that it's less than epsilon.
Okay.
So the same thing in less than or equal. So
Okay.
also I need to return a result. It's also
Yeah, you want to return the result.
yeah, return. All right, let it be result. Result. Oh.
You want to
I'm not
closing bracket. Yeah, because the for loop has not been.
Here. This is while. This is
okay, right there. Okay.
And
just
this
return.
is the last. It's So no. Yeah, you're right. It's this is inside for loop, and I close bracket in
Yes.
for loop, and now try to return the result. Camera. Result const double result equal to best result angle, best result angle minus field of view divided by 2, right? field of view or not. Just let me think. Yeah. Oh no. Plus, just a moment. We have let it be the best view. So we found like this one angle, and we know that in this case we can go. So we just need to add only half of field of view, right? So field of view divided by 2 or multiplied by 0.5. I guess it doesn't matter. Multiplied 0.5. And we need to take a modulo of this one, std f mod or std f mod by mod by 2 pi pi
Okay.
and return a result.
Okay, I have 2 questions. What is the return value of this function?
Sorry, can I repeat?
What is the return value of this function? Let's say that you have 2 angles, angle 1 and angle 2, and then
it's a fixed. I mean, we fix order of this, so it's not the shortest angle. It's already calculated angle.
So it is there.
Right.
Like we have points here, and the left point is there, right point is there.
All right.
And then we're going to put them into that function. And what is the return value of?
Return value will be like angle distance in angle space.
Okay.
So
Yes. All right.
between 2 points.
I see. And then what you're going to store here? What is the best result angle?
Yeah.
Is
I update it all the time. Like you said.
So the best result angle means the angle or the beginning of the angle or the finishing?
Yeah. It's a big. Yeah, it's my bad. Wow, nice. It's gonna be beginning of the angle.
Okay.
So
I see.
So in update I need to write. Oh, it's so stupid bug. It's best result angle or points and angle. And angle, our left bound, and this is a second. So yeah, it's so stupid, but it's pretty simple to find it when you write some kind of text.
I see. So that now this makes sense.
Yeah.
Because I thought that the best result angle should be the like half of those angles. But no, you're right. If it's a left-bound angle, you're going to add the half of field of view.
No, it makes sense because
yes, I understand.
For example, if it will be here, so we add a half of field of view, it's going to be here, but we will obtain. So we need to take model by 2 pi.
Yeah, I understand. Yeah, because I thought that the best result angle again is the center of
it's
those.
My bad.
Center of the camera angle, not the left bound of the. I think it's totally fine. Okay. Question: testing. How would you test this function?
Great idea. We need to check also. At the beginning, it's pretty simple. We need to write some pretty simple tests when, for example, 1 point or. At first, check 0 point because
yes,
and check 0 field of view and check 2 pi. All right. After that, we need to bit more harder. For example, just 1 point and try to see the result. What will be here and what, for example, if some points will be on the camera position, it will be the hardest way. So we need to write to remove all points which in camera position and add them to the answer at the beginning. It's the right solution. So I need to write this or
no? 0 points, like a field of view less than 0 or larger than 2 pi. And the points on a camera center, and anything else.
Maybe I try to Also, we need to add this. We need to compare like this one because it's doubles. And
Yeah.
Maybe it's integer points. So in this case, it will be easier. So,
Okay.
and also, you know how to find the angle. It's,
Yeah.
I already mentioned one.
Yeah. Yeah, it's fine.
Y
Yeah.
and x.
Yeah.
So what else?
How about the shape of points?
Shape of points?
Yeah.
What means? Sorry. Shape.
Yeah, based on the points, we have many points, and then if they are evenly distributed on two-dimensional space, it's fine. If not, let's say that if they are if they have some structures.
Oh, it makes sense, but we solved it's not a big deal. It will work linear time anyway.
Yes.
Because
yes.
the time complexity, it's a comparison of just copy all this array or loop over this array. Array it's maybe twice longer. So
okay.
Anyway, for special structure, maybe possible to find maybe log n, but it's should be really. We can mount n, for example, like quad tree and see something, or
yeah.
I think
that makes sense.
Because we can also, for example, maintain some segment tree or some kind of tree and try to answer queries on for each segment. It's also easy.
Yeah, quadtree structure, angular quadtree structure would be an easy way to get the points. Let's say that like reverse the problem.
For example, if you have a lot of queries, how many points from this side, from this, so it's pretty easy to answer in logarithmic time for any structure.
Yes, but actually, even in the case, the time complexity doesn't change at all. It still is n log n.
For any structure, it will be log n. But for sorting, n log n.
Yes. Yeah. Cool. Yeah. Now it is your time to ask a question. Do you have any question to me, to anything, to my personal stuff? Do you have any?
Sure. How reorganization in your organization influences the regular employees in your organization?
Yes. The key point is that the setting up the missions for every employees in the organization, and if the employee's mission is not aligned at all with the goals of the product goals or the service goals of that organization, there's a problem. But I believe all the people in the team in these organizations are strongly aligned with the the product area's goal. So it goes well. And then if it actually is your role once you join, if you believe your mission is not aligned well with the company's goal or the group's goal, it is your responsibility to change your mission to align with them. If you cannot change, well, that's the time to leave the company.
So, I see. So,
okay, how to think about it? What score do you want to give him? Okay, let's compare it my feedback. Coding, I think he has fairly good coding skill. Unfortunately, his code doesn't look well organized on a whiteboard. If he could write a code on a computer, he should be much better, but at least on a whiteboard, his code doesn't look well organized, or I couldn't read any coding style. But basically, he does not have any problem in implementing his idea. While he was coding, he made several mistakes. I gave him several comments and then he fixed. Unfortunately, his coding seems a little bit slower than other candidates. After coding, he proposed actually several edge cases and he addressed most of them. Analytical skills. It is clear that he has a very good algorithm analytical skills and also he has a strong math skills. Communication. He is Russian, his English skill is not really perfect, but I see that he does not have any problem in communicating with other engineers for talking about engineering topics. Sometimes he needs to repeat what he said, but I think it is purely because of his language skills, not communication skills. In general, he knows how to communicate with other people. And I see that he has good potential to improve his communication skills further. And overall, during the interviews, he demonstrated quite strong technical skills. So I would give 2.9, mainly because his coding is a little bit slow and then his code doesn't look well organized. But still, the 2.9 is quite high score. 2.5 is a borderline, 3.0 is a quite high score, and 2.9 doesn't hurt anything. If all other interviewers give high scores like higher than 3.0 or the strong review result, this does not hurt anything. He wouldn't have any problem on passing his interview. Overall, he has strong analytical and math skills, and coding looks good but not strong. Again, his coding is a little bit slower than other candidates, but in general, it is fine. Again, in this session, we watched another video of on-site interview example. The candidate got his bachelor's and master's degree in computer science, and previously he had several software engineer internship experiences. Overall, he is quite strong candidate and definitely above the bar, and I believe he wouldn't have any problem in demonstrating his strong technical skills in other interviews. That's it for another example of on-site interviews.